Welcome back to Geometry, Measurement, and Probability. In this video, we talk about section 13.3, where we look at the Pythagorean Theorem. So let's get started. First, let's think about the parts of a right triangle. So draw a right triangle. The hypotenuse is the side across from the right angle. The other two sides of the right triangle are called legs. The Pythagorean Theorem tells us that a squared plus b squared equals c squared, where a and b are legs of the right triangle and c is the hypotenuse of the right triangle. In example 1, we are asked to find x. Notice that we have a right triangle, so I can use the Pythagorean Theorem. A squared plus b squared equals c squared. Label your sides on your triangle. A and b are the legs of the triangle, and c is the side across from the right angle, so c here would be 7. Plug into the Pythagorean Theorem. A is 5, b is x, and c is 7. 5 squared is 25, and 7 squared is 49. Subtract 25 from both sides. That gives us that x squared equals 24. Use the square root property to solve this equation, and that gives us that x equals the square root of 24. Now, typically with the square root property, we use a plus or minus on the side with the square root. But because in geometry we do not have negative links, we don't have to worry about that minus here. There are two ways we can write our answer. Read your directions in math labs to see if they want the answer with the radical or as a decimal. If math labs ask for an answer with a radical, then I need to simplify square root of 24. Well, I know that 24 is 4 times 6. I chose 4 because 4 is a perfect square. 6 is 2 times 3, so it's not a perfect square. The square root of 4 is 2, and then bring down that square root of 6. Our units here, we are not given, so we just call them units. You can also type in square root of 24 into your calculator. Read math labs carefully to see how many decimal places they ask for, and here you would get 4.899, and again our units are just units because we don't know if they're inches or feet or miles or meters. Notice here I used the approximately symbol because we did round. Look at example 2. The size of a rectangular television screen is given as the length of the diagonal of the screen. We know that the length of the screen is 24 inches and the width is 18. And the question asks, what is the diagonal length? Notice your picture already has A, B, and C labeled. We have a right angle with the television, and so we can use the Pythagorean Theorem. A squared plus b squared equals c squared. A is 18, b is 24. 18 squared is 324, and 24 squared is 576. Add these two numbers together on the left side gives us 900. Use the square root property to solve, and so here c is the square root of 900, which is 30. Our units here are inches. Now look at example 3. We have a pole that's 28 feet high and is perpendicular to the ground. That's going to be segment BD. Two wires, each 35 feet long, are attached to the top of the pole and to stakes A and C on the ground. You'll see that in segment BA and segment BC. Points A, D, and C are collinear, and we want to know how far are stakes A and C from each other. I'm going to start by looking at triangle ABD. I notice I have a right triangle, so I can use the Pythagorean Theorem. A squared plus b squared equals c squared. I'm going to let A be the length from A to D. B would be the other leg of the triangle, which is 28 feet, and C, the hypotenuse, is 35 feet long. Plug into the Pythagorean Theorem. B is 28 and C is 35. 28 squared is 784, and 35 squared is 1225. Subtract 784 from both sides, and we get that A squared is 441. Use the square root property, so A is the square root of 441, and that would be 21, and our units here are feet. Now I need to think about the length of DC. This triangle ABC, is an isosceles triangle. That tells me that BD, that altitude, comes down in the middle of segment AC. So AD and CD are the same length, so CD would also be A. AC then is A plus A, or 21 feet plus 21 feet, which is 42 feet. Now look at example 4. How tall is the Great Pyramid of Cheops, a right regular square pyramid, if the base has a side of 771 feet and the slant height is 620 feet? So first I want to think about a right triangle. So notice in the pyramid I have a right triangle. A is going to be EF. We're going to let B be DF. And our hypotenuse of that right triangle would be ED. Now DF is going to be half of one of the sides of the triangle because that height comes down to the middle of that square pyramid. So DF is half, I'm going to call that left-hand corner G, so it'll be half of AG. So here, half of 771, or 385.5. And now I can use the Pythagorean Theorem. Plug in for B and C. Type in 385.5 squared into your calculator, as well as 620 squared into your calculator. Subtract 148,610.25 from both sides to solve for A squared. Use the square root property, so A is the square root of 235,789.75. Type this into your calculator and you get that A is approximately 485.58 feet. Now, look at the converse of the Pythagorean Theorem. The converse of the Pythagorean Theorem says that if A squared plus B squared equals C squared, then our triangle is a right triangle. Here's how that works. We want to know if each of the following can be the lengths of the side of a right triangle. Well, if we have a right triangle, C is always going to be the longest side. So in part A, C would be 85. And that means that 51 and 68 are A and B. I want to see if the Pythagorean Theorem holds. So I'm going to plug in 51 for A, 68 for B, and 85 for C. 51 squared is 2,601. 68 squared is 4,624, and 85 squared is 7,225. Add your two numbers on the left side, and you do get 7,225, and so this one could be the lengths of the right triangle. Look at part B. We have a square root. I need to know which of these sides is the longest, so type square root of 13 into your calculator, and you get approximately 3.6. That tells me that C is the square root of 13, the longest side. 2 and 3 would then be A and B, and plug this in to your theorem. Plug in 2 for A, 3 for B, and square root of 13 for C. 2 squared is 4, and 3 squared is 9. When you square a square root, the root goes away and leaves us with 13. 4 plus 9 is 13, and so these could be the sides of a right triangle. Now look at part C. C is always the longest side. The other two sides would be A and B. See if the Pythagorean Theorem holds. Notice I put a question mark each time over the equal to sign. Plug in 3 for A, 4 for B, and 7 for C. 3 squared is 9, 4 squared is 16, and 7 squared is 49. On the left side, 9 plus 16 is 25, and this does not equal 49, and so these cannot be the sides of a right triangle.